Cikgu, you are muted.
Aduh, ya awak ni. Cakap seorang-seorang lah pula. Tak apalah. Ya, saya balik. Selamat pagi, selamat sejahtera. Yang ni saya record balik you boleh tengok. Yang saya tulis ni, record balik yang 5.1. Saya mute tadi anak saya. Okay, the definition of thermionic emission, emission of free electron from a heated metal surface. Cathode rays, definition of cathode rays is a high-speed electron beam, okay, or electron beam that move at high speed, cathode rays. Thermionic emission, emission of free electron from a heated metal surface. Okay, and then the characteristic of cathode rays, we have at least 5 here. Okay, move at a straight line or travel at a straight line. Why we know that it moves at a straight line? Because when we investigate with the multi-cross tube, it will form a shadow on the fluorescent screen. So it means that the cathode ray move at a straight line. Yeah. Number 2, it is negatively charged because it bends toward the positive plate by using positive and negative electric plate. Okay, electric field. Negatively charged. Number 3, can be deflected by electric field. Number 4, it also can be deflected by magnetic field. Okay. Magnetic field ni kita guna magnet. We bring a north pole magnet closer to the multi-cross tube, then there is another shadow. There is another shadow formed on the screen. So there are 2 shadows. First shadow from the light, and second shadow from the cathode ray. So the cathode ray can be deflected by magnetic field. Okay, it moves downward a little bit, distorted, okay, by the magnet. Okay, this one electric field yang tak sama dengan negatif tadilah. Okay, it bend toward the or deflect towards the positive plate. Okay, then kinetic energy and momentum ni, this one will look at the green, the green fluorescent screen. Okay, so means that the cathode ray move at high speed. It has kinetic energy and also momentum. So outside the shadow, the green screen will appear. Okay, ada kawasan yang warna hijau. It is for 5.1. And then the last one we relate with the conservation of energy. Yang bahagian atas ni, dia relate dengan conservation of energy, which is kinetic energy equal to electrical potential energy. Okay. So yang inilah. Okay, yang ni yang potential energy. Conservation. Okay, conservation of energy. Kinetic energy equal to electrical potential energy. EV. Okay, EV ni kena ingat electrical potential energy, EV. E equal to EV. Okay. Then for 5.2, 5.1 tak ada nak tanya. Tak ada masalah. Characteristic, conservation of energy, definition, thermionic emission and cathode ray. 3 benda lah kena ingat. Okay, next we look at the semiconductor diode. Okay, we learn about diode. Nampak tak ni? Right. Okay, you have learned that transmission of electrical power to consumers through a network in the form of AC. Okay, ini dah relate balik dengan transmission. Okay, AC current. Kita terima AC current yang masuk ke dalam rumah kita adalah AC current. Okay, but in your house there are too many electrical device that only function with direct current. So banyak yang guna direct current. So therefore we need another electrical component to convert the alternating current to direct current. Okay, from alternating current to direct current. Okay, our live wire, we have 3 types of wire, right? Live wire, neutral wire, and earth wire. So the live wire will send the voltage or the current from the main substation, okay, to our home, our house, 240 volt. So that is alternating current. We receive alternating current. So we want to convert the AC current to direct current. Okay, in order to convert the AC to DC, we need a diode, semiconductor diode. So this is the structure of the diode. Ini punya symbol. This is the symbol. Anode and cathode. So the silver color here is negative and the black color is positive. Okay. So positive, negative. The symbol, triangle, and one vertical line here lah. Okay, at the end. Positive, negative. Okay, positive anode. So this is anode. This is cathode. Okay. Then we need to connect this to the positive. Okay, positive, negative. Okay, kena sama. Terminal dia kena sama. Positive to positive, negative to negative. Okay, because inside the diode we have electron and hole. Okay, so the electron will move toward the positive. Okay, the electron will move toward positive. The hole will move towards the negative. Right. Introduction. Okay, this one activity to discuss the function of semiconductor diode. Look the connection. We have positive. Okay, we have positive, positive. This one negative to negative. Okay. So ini for diode we have 2 type of connection lah. Forward bias and reverse bias. Okay. Forward bias and reverse bias. Okay, forward bias and one more is reverse bias. Okay, forward bias is the connection that allow current to flow. Okay, macam ni lah, positive positive, that is forward bias. So the current will flow. The current can flow through this circuit. But for reverse bias, so you reverse the connection. Either you reverse the diode or you reverse the terminal of the battery. Positive, negative, negative, positive. So this is a reverse bias connection, reverse bias circuit. So this one there's no current flow. Okay, the bulb will not light up. Okay, the bulb will not light up. Only in forward bias, the bulb will light up. Okay. Reverse bias. Okay, yang ni this one is reverse bias. Positif, negatif, negatif, positif. Reverse lah. Okay, sepatutnya positif dengan positif. Okay, type of connection. Right. Okay. Next page. Okay, the function. Ni kejap je. Dia nak function dengan apa lagi? Kita ada converting, dia punya graph. Kita tengok dulu dia punya function of semiconductor. Okay. Semiconductor diode is an electronic component which allow electric current to flow in one direction. Okay. Function of diode. The function of a semiconductor diode. Allow current to flow in one direction. Allow current flow in one direction. Ni kena ingatlah function diode. What is the function of diode? To allow current to flow in one direction only. Okay. So this diode is formed by joining by combination of p-type semiconductor and n-type semiconductor to form a p-n junction. So basic dia adalah daripada semiconductor silicon. Okay, we make a diode from a silicon. So this silicon, kita tengok dia punya pembentukan dia dulu dekat sini. Boleh nampak Okay. Cara nak buat ataupun dari mana diode ni, macam mana hasilkan diode ni. So kita ada dua jenis. Kita kena buat semiconductor dulu. We need to build a semiconductor first. Okay, semiconductor is formed by a silicon. Dia punya basic structure is silicon. Silicon, if you learn in a periodic table, silicon is the semi-metal, right? It can be an insulator, it also can be a conductor, a good conductor. So that's the characteristic of the semi-metal lah. So we use silicon. Okay, to make a diode, we need to combine two type of semiconductor, p-type and n-type. Okay, so there's p-type. Okay, p-type. And here, the right one, n-type. Okay, p-type, n-type. P positive and negative. Okay, P positive and negative. P-type conductor, okay, P-type conductor ataupun positive. Okay, positive type of the semiconductor, it have extra hole. Dia ada extra hole. Nampak yang biru kecil ni adalah hole. Kenapa dia ada extra hole? Because the silicon we dope. We call the process to make p-type and n-type is the doping process. Okay, doping process. Okay. So we dope the silicon with the dopant of, let's say here is boron. B boron, right? Okay. So boron got 3 electron valence, silicon got 4 electron valence. So 4 and 3 make a hole. Okay, so the silicon got extra hole. Okay, got extra hole because boron only got 3. When it combined together, it will produce hole. Okay, produce one hole. So for extra one hole here, will produce p-type semiconductor. Okay, p-type semiconductor. Banyak hole, positive. And for n-type semiconductor, we combine the silicon with the arsenic. Okay, arsenic, it has 5 electrovalence. Okay, valence electron dekat luar. So 5 and 4 we have extra electron. Right? So this, if the semiconductor has extra electron, it will become n-type, negative type semiconductor. Negative because it has extra electron lah. Okay. This one, for n-type semiconductor, we combine the silicon, we dope the silicon with the pentavalence atom, arsenic. For p-type, we dope the semiconductor with trivalent atom. Okay. Boleh for this one, doping process. And then to make a diode, we need to combine P and N. Okay, P and N combine together to become a diode. Okay, okay, become a diode. To make a diode, we need to combine positive and negative type PN. So PN junction. Sekejap. Okay, ini balik. Right, this one a doping process. Doping. Doping means we combine the silicon with another atom, okay, to become p-type or n-type semiconductor. Okay, and then to make a diode, we combine again p-type semiconductor with n-type semiconductor, or PN, to produce PN. So here in between P and N, we have a depletion layer. Okay, dekat tengah-tengah ni ada line warna hitam kan, ada dot line here. So this is a depletion layer. Dekat tengah ni nanti ada depletion layer. So dekat kawasan ni akan there will appear a depletion layer. So for this depletion layer, the electron will move to the left and the hole will move to the right to be filled each other lah. Okay, so electron ni akan fill in the hole, or the hole will come to the right side to be filled with electron. So there will a depletion layer in between P and N. Right. Okay, mana yang tadi ni? Okay. Ini yang tadi, the type of the circuit, forward bias circuit and reverse bias circuit. Okay. So dekat sini kita boleh tengok, okay, we have a thin depletion layer, and reverse bias we have wide depletion layer. So this is the diode lah. Okay, this is diode, positive and negative. Positive the black color one, negative is the yang grey, yang silver color tadi. Positive and negative. Combination of P-type and N-type semiconductor to form a PN junction. That is diode. So here you can see, okay, when we switch on the circuit, or when the circuit is closed, the circuit complete, the current will flow. Okay, and then it make the electron move to the P junction, and the hole move to the N. So the depletion layer will become thinner and thinner because both of them fill in each other. Yeah, and the bulbs will light up lah, means the electron can flow and complete the circuit. Okay, the electron can flow and complete the circuit. And remember the current from positive to negative. Okay, from positive to negative, but the electron move from negative to positive. Okay, to the left. Electron move to the left. Current move to the right, from left to right. Okay. So dekat sini current move from positive, but electron move to the negative. Positive, negative, negative, positive. Ini dia opposite dia punya flow, current and electron opposite. Right. Hmm. Nak kecilkan sikit. Right. When a diode is forward bias, so dia punya connection yang macam tadi positive forward bias, the hole will move towards the N type. The hole move to the N type while the electron move toward the P type. So the depletion layer become thinner. Okay. The junction voltage V, okay, the junction voltage V here decrease and the resistance of the anode become very small, so the electron can flow lah, causing the bulb to light up. Okay. And for reverse bias, opposite mana? Okay, when a diode is in reverse bias, the hole and the electron will both move away, so in opposite direction. If you look here, this one is positive, this one is negative. So you dah reverse bias. Sepatutnya P dengan positif, N dengan negatif, but you reverse the terminal of the battery, it will become reverse bias circuit. So for reverse bias circuit, the hole will attracted to the negative, and electron in the N type will attracted to the positive. So the depletion layer become wider and wider. So voltage increase, the resistance also increase, make the current cannot flow. Resistance increase, okay, because of the voltage increase here, the current cannot flow lah. The bulbs will not light up. Okay. Boleh? The difference between forward bias circuit and reverse bias circuit. Okay. You kena explain about the depletion layer lah. Okay. The size of the depletion layer. The depletion layer become from the combination of P-type and N-type that produce PN junction. Dia punya junction dekat sini. Ada tengah-tengah ni ada junction lah. Okay. The use of semiconductor diode and capacitor in the rectification of alternating current. Okay. So just now the new words here is rectification. Rectification. So rectification is the process, okay, the process to convert AC to DC. Process of converting AC to DC. Rectification of alternating current. Okay, how does a semiconductor diode convert an AC to DC? Look at the next page here. Yang ni banyak kid tak tahu dekat sekolah ada ke tak? Apa kid ni? Right, rectification, the process of converting AC to DC. Ni maksud definition lah. What is rectification? Rectifier. Diode as a rectifier to convert AC current to DC current. Ini dia punya kit. Kita keep lah yang ni. Tengok kepada yang ini. Okay, we have two type of rectification. We have half wave and full wave. Okay, we have half wave and full wave. Okay, kenapa ada half wave dengan full wave? Yeah, because we know that AC current can move either from positive to negative, okay, positive to negative, and the other way around, negative to positive. So kalau AC, dia akan ada electric current can move in two direction, positive, negative to positive. So that's why here in rectification we have two type of rectification, either half wave only or full wave rectification. Half wave maksudnya separuh jalan saja. Kalau full wave, in both direction lah, positive and negative both. So we look at half wave rectification. So this one, it only use one diode only. Okay, one diode. So, baca dekat sini. During the positive half cycle, the semiconductor diode is forward bias. So, kalau kita buat connection macam ni, okay, and then we consume that the current flow from positive to negative first lah. Okay, from positive to negative. Means here from positive to negative. From A to B. Let's say from A to B. Okay, from A to B is a positive half cycle. So the current can flow through the circuit, through the diode, because the diode is in forward bias. Kita sambung dia positive. So current can flow. Okay, current can flow. For the first half cycle, A to B. Okay, first half cycle, positive half cycle, A to B. Okay, there is current flow. Okay, so this positive half cycle from A to B. Ni dia punya come out ada CRO lah. Dia punya graph. From A to B, the graph will be like this. And then, if the current flow, we know that AC, current flow two ways, right? Okay, yang tadi dah A to B, and now second half cycle B to A. Okay, B to A means that the diode is in reverse bias. Reverse bias from B to A. B to A is in reverse bias. So there's no current flow. No current. So no current. For negative, let's say here got negative. Not supposed to be negative. So but now the diode's in reverse bias, there's no current flow lah. So dia akan jadi flat. The graph will be flat like this. And then continue. Continue the current flow from positive to negative or A to B again become the graph become like this again. Okay, the bumper lah. So got positive, 0, positive, 0, positive, 0. And why 0? Because this one the diode is in reverse bias. Okay, ini yang ori. This one the graph, original graph lah for alternating current input. Okay, kita ada positive, negative. And then for dia punya come out become like this because we use diode. Okay, the function of diode is to convert AC current to direct current, which is one direction only. Okay, boleh dengar saya ke tak ni? Kedengar. Yang ni boleh Kenapa graf dekat CRO jadi macam ni? Okay, sebab kita guna satu diode. So if the current move from A to B, okay, let's say from positive to negative, so the graph, there is current flow, there is a graph appear, positive. And then from B to A, okay, it become reverse bias circuit. So there's no current flow. Okay, so no graph lah, no current, so 0. Current is 0 here, right? Voltage is 0. Okay, that one for half wave rectification. Okay, half wave rectification. Okay, for full wave, okay, we look at full wave. Full wave we have 4 diode. We use 4 diodes. Okay, sebab kita nak positif ada, negatif pun ada. Okay, the current flow in positive half cycle and negative half cycle, but still the come out is direct current from AC current to direct current. Okay, right here we use a 4 diodes, okay, that we call it a bridge rectifier. Okay, if there are 4 diodes, we call it bridge rectifier. Okay, bridge rectifier. So the diagram look like this lah. Okay, right. So dekat sini for positive half cycle, so we consume positive at the top lah, positive to negative, or from A to B. From A to B, okay, from A to B, the current the current or voltage, the voltage will flow through D1 first. D1, okay, through D1, go back to the resistor, okay, resistor to control the current, and then to D2, D1 and D2 to B. Okay, that's positive half cycle. And for negative half cycle B to A, the current will flow through D3. D3 first, go to the resistor, okay, and then go to D4, go to A. Now from B to A, the voltage flow through D3, resistor, and D4 to A. Boleh nampak? Boleh nampak tak dia punya pathway tu? Okay, mesti melalui resistor dululah. Okay, mesti melalui resistor. Right. That is a positive half cycle. Ini saya dah tunjuk dua-dua sekali. Okay, yang positive half cycle maksudnya dia akan melalui D1 and D2. D1 and D2. Dan ada soalan dia akan kosongkan, dia akan buat petak kosong. Dia akan kosongkan. Nanti dia akan minta you lukis arah diode ni macam mana. So you kena careful lah. Kena ikut laluan yang betul. So the diode must be in forward bias. Positif. Mesti in forward bias. Jangan lukis terbalik pula. Jangan lukis terbalik. Ataupun you buat sama je dia punya laluan ni. Okay. Itu tak boleh. Yang ni kadang-kadang akan adalah soalan yang minta you lukis. Structure question. Number 1 until number 5. Untuk lukis. Ataupun soalan belakang. Okay. And then for negative half cycle. Okay, negative half cycle pun sama macam tadilah. Means that the current flow from B to A. From B to A. From negative to positive. So from negative to positive, the voltage flow through D3 to R and then to D4. Okay, D3, D4, negative half cycle. Because the diode is in forward. Okay, tengok from B to A. Okay. From B, it will flow through D3 because D3 is in forward bias. It cannot flow through D2 because D2 is in reverse bias. So tak boleh. It must flow to D3. Okay, go to resistor and then to D4 lah. D4 in forward bias and then back to A. From B to A. This one for negative half cycle. B to A or negative to positive. Okay, boleh. D3 and D4. For the positive half cycle, D1 and D2 from A to B. This one from A to B. So come to the D1 lah. In forward bias cannot go through D4. D4 is reverse. Tak boleh. So kena dalam forward bias. Okay. So go through resistor. Okay, cari lagi mana yang forward bias. Okay, D2. D2. D3 tak boleh lah laluan yang sama. So must be flow through D2 and go to B. Okay, A to B. This one B to A. Ataupun positif, negatif, negatif, positif. Right. Boleh? This one D1, D2, this one D3, D4. Tengok dia punya susunan dia ni. Mesti for the opposite diode, dia punya direction is same. Okay. Right. Boleh Ini sebagai contoh lain lah. Okay. So, yang ni, ini AC current. Okay, AC voltage supply. So, saya suka guna ni A dengan B, senang nampak. So, from A go through number 1, number 2. Okay, saya buat number 1, number 2, number 3, number 4. Ini saya hanya buat saja nombor. So, yang mana dulu For this one, which one? From A to B. Positive half cycle from A to B. So it will use diode number 1. Okay, diode number 1. Right? And then one more, diode number 3. Okay, diode number 3 ni litar ni tak lengkap. Litar ni tak berapa nak lengkap ni. Dekat sini ada resistor lah. And then baru CRO, graph. Okay, from 1 to resistor to 3. Okay, 1 resistor to 3 and then to B. So number 1 and number 3. Diode number 1 and diode number 3. And then for the negative half cycle from B to A, it will go through diode number 2. Okay, diode number 2 lah. Okay, dekat sini. From B, diode number 2 to resistor and then number 4. Number 2 and number 4. Okay, dia akan ulang alik. So the graph will be for the positive half cycle, okay, from A to B. From A to B, the graph come like this lah. Okay, positive. And then, tak cukup ruang. Okay, and then for B to A, B back to A. So the graph also positive. The graph also become like this because the current can flow, right? The current can flow to the circuit. The diode is in forward bias 2 and 4. 2 and 4 from B to A. So in forward bias. And then A to B again. A to B. Okay, A to B. So samalah. So graf akan jadi macam roti ban lah. Semua dekat atas. Semua positif. A to B, B to A to B, B to A. So semua akan jadi dekat atas. This one for bridge rectifier yang guna 4 diode. Okay. So A to B, it using diode number 1 and number 3. Okay, 1 and 3. B to A, number 2, number 4. Okay, continuous lah. That is for bridge rectifier. Okay. Yang tadi, yang apa? Yang ni, kita hanya guna satu. So, kalau satu, dia punya graph yang positif macam ni lah. Okay. And then, untuk yang B to A to B, positif. B to A, tak ada. Because this one the diode is in reverse bias. Kita hanya guna satu sahaja diode. And then A to B again. Naik lagi. Dan flat. Naik. Flat. This one for half wave. Okay, half wave rectification. Okay, half wave. This one yang tadi full wave. Okay, full wave. Yang ni full wave. Full wave rectification to convert the AC current to direct current using 1 diode and 4 diode. 4 diode bridge rectifier for full wave rectification. 1 diode for half wave rectification. So graph lain-lain lah, different. Right? Ada soalan nak tanya? Setakat ni ada tak? Boleh ya? Okay. Next. Full wave rectification. Ini dia punya graph lah. Sama macam yang saya explain tadi lah. This one dia guna diode. D1, D2, D3, D4, D1 to D2 positive. Okay. D3, D4 also positive. Okay. From AC current, from the input voltage, okay, from the power supply is AC. Now we want to convert to DC. So dia punya graph like this lah. This one for full wave rectification. Okay. That use both half of every cycle. Okay. So in same direction. In same direction. All positive. Okay. Because we use 4 diode, we can change. We can change the current flow. The voltage flow. Okay, boleh Ini sama macam saya explain tadi lah. From A to B, B to A to B, B to A. Okay. So yang negatif tadi kita dah tukar jadi positif. Okay, semua dah jadi positif. Right. Okay. And then we have a 3 type of graph here. Okay, this is AC current. Okay, this one is AC current lah, the input. And then this is direct current. Okay, from the AC current, we change to the DC current by using 4 diodes. So the graph become like this. Okay, jadi apa ni? Nak panggil apa ni? Macam kalau bumper dia satu-satu je. Okay, and then we want to convert this DC current to become like this, to make it smooth. Okay, to make it smooth or a steady direct current. Okay, kalau kita guna bateri, dia punya direct current macam ni lah. Kalau tengok dekat CRO, the screen, fluorescent screen at CRO, for direct current from the battery, the graph will horizontal line like this. Okay, so we want to convert here DC to this one, but we cannot produce the smooth like that lah. Okay. Okay, now how to make it smooth? To smooth the current, we use capacitor. Okay, we use capacitor. Okay, sekarang we use capacitor in smoothing direct current. Half wave and full wave rectification produce a direct current which is not smooth. Ini tak nampak smooth kan? Ini dah macam bukit-bukit ni. So we need to use a capacitor to smooth the current in a rectification circuit. Right? Okay. Smoothing of half wave rectification. So, right, we put a capacitor connected in parallel to the resistor. Okay, so capacitor parallel to the resistor. Ini simbol capacitor lah, parallel line. Okay, capacitor dia ada 2 kaki. Tengok, ini saya cari tadi. Capacitor dia 2 kaki sama dengan LED. Lambat pula. Nampak lah line ni. Ini nampak tak bentuk capacitor. Ni semua dalam electronic component yang bulat yang macam cube, yang cube-cube yang 2 kaki tu adalah capacitor lah. Okay. Dia lambat sikit. Yang ada 2 kaki tu adalah capacitor. Yang 3 kaki transistor. So, nampak lah tadi. Dia lambat sikit respon ni. Lah. Okay. So capacitor dia punya simbol sama, jangan buat satu panjang satu pendek. Satu panjang satu pendek tu adalah bateri. So kalau capacitor mesti sama. Sama, kaki dia sama. Ini baru muncul kat sini apa hal. Okay, ini kapasitor yang dua kaki ni. Dia LED pun dua kaki juga, tapi satu panjang, satu pendek, kan? Yang LED yang lampu, light emitter diode. Tu pun diode juga yang dua kaki. LED pun adalah diode. Ada cathode, ada anode. So this one is capacitor. We use it to smooth the current. Okay, we must put opposite. Okay, opposite or parallel to the resistance. Okay. When the power supply is turned on, the output current become smooth. Okay, the output current become smooth. How it function? It store the charge. It charge and discharge. It charge and discharge. So if you can see the graph here, okay, so tengok graph tu. Okay, when the current increase or voltage increase, the capacitor will store. Dia akan store. So dekat sini, the capacitor is charging. Okay. Once the voltage increase or potential difference increase, the capacitor is charging. Okay, capacitor is charging. Okay, and then the capacitor will discharge. Okay, when the potential difference decrease, dia dah nak turun, bila nak turun, okay, nampak yang tadi yang pink ni, dia nak turun, and at this time the capacitor will discharge and will not allow the voltage to become zero. Okay, it will store. Dia akan simpan charge tu sehingga voltage tu akan return to increase again and it will charge again. Okay, so akan charge, discharge, and continuous lah. Yeah, until sampai habis lah. Okay, selagi ada current, AC current. So dia akan graph akan continuous. Charge, tak cantik. Charge and discharge. Charge, discharge, continuous. Okay, so yang dekat sini dia charge. The capacitor charging. And bila dia turun, yang turun, kawasan turun ni adalah discharge. Okay, discharging. So graph dia tak adalah smooth macam direct current, tapi dia make it smoother a little bit. Okay, yang bukit-bukit tadi dia smoothkan sikit. Alright. So same goes to the for full wave smoothing or full wave rectification. Output pun samalah. Okay, yang output tadi kan dia punya hill tu continuous. So sama. Charging, discharge, charging, discharge, charging, discharge, charging, discharge. Okay, dia akan smooth the direct current that produce. Okay, smooth the direct current. Right. Boleh ha? Tengok dekat sini, when the voltage increase, the capacitor charge or store the voltage. And then when the voltage decrease to zero, the capacitor still hold the voltage it store. It discharge, charge, discharge, charge, discharge. Okay. Itu dia punya working lah. Okay, working principle of the capacitor. When the potential difference decrease, the capacitor will discharge so that the output current does not fall to zero. Okay, it prevents the output current from fall to zero. The energy stored in the capacitor will maintain the potential difference across the resistor. Okay, dia akan maintain voltage tadi. Okay, the smooth output waveform shows that the capacitor is functioning as current smoother. Okay. If the question asks what is the function of a capacitor, the function is a current smoother or smooth the direct current. Right. Okay. Then for 5.2 habis. Ada soalan nak tanya? Tak ada. Now for today you belajar doping. Okay, doping yang tadi ya. Doping for P-type and N-type tu dari mana datangnya diode. So kita start dengan semiconductor. Okay, semiconductor, semi-metal, silicon. Okay, to make a diode, there is a process called doping. Okay, doping process. Okay, combination. We use foreign material combined with the semi-metal, okay, or silicon to become extrinsic material. Tu kalau you tengok, you search lagi ataupun you cari syllabus yang lama, dia akan explain sikit lah tentang doping ni. Syllabus lama, kalau ada abang ke kakak ke yang ada syllabus lama, yang ada reference book yang lama, so boleh tengok ada dia punya doping. Okay. So untuk hasilkan diode, kita kena hasilkan dulu semiconductor. Okay, two type of semiconductor, P-type and N-type. Doping for P-type and N-type. Okay, P-type, N-type. Okay, and then baru kita combine dua ni untuk hasilkan diode. So P-type and N-type. P-type, we combine silicon dengan trivalent electron. Okay, boron contoh boron lah tadilah. Other than boron apa lagi? Germanium berapa? Okay, this one for P-type. And then for N-type, we combine silicon with pentavalent electron. Okay, pentavalent atom. Arsenic. Okay, arsenic. So this one will produce N-type semiconductor. Then combination of P-type and N-type will produce PN junction or diode lah. Okay. So in between P and N-type ni ada depletion layer. Okay, ada depletion layer. So if we connect the diode, okay, this diode in forward bias, okay, kita ada dua jenis circuit, forward and reverse. Okay, forward and reverse bias. Okay, forward bias, reverse bias. So forward bias, the current can flow. Reverse bias, no current flow. Okay, boleh. Forward bias, when the depletion layer between P-N junction becomes smaller or thinner. And reverse bias, why current cannot flow? Because of the depletion layer become thicker. Depletion layer between the P-N junction become thicker. That's why the current cannot flow. Right? And then you learn about full wave dengan half wave rectification. Okay, kita kegunaan diode lah. Okay, the use of diode. The use of diode as a rectifier. Okay, rectifier. So what is rectification? A process of converting AC to DC. So kita ada two type, which is half wave dengan full wave. Okay, half wave, full wave. So half wave yang guna satu diode sahaja. Full wave kita guna 4 diodes. Okay, 4 diodes, or we call it bridge rectifier. Okay, bridge rectifier. And then you kena tahu dia punya graph lah, output graph. Okay, dia punya output voltage macam mana. Okay, and then capacitor tadi. The use of capacitor as a current smoother. Okay, current smoother. Charging, discharge, charging, discharge. And then you kena tahu lukis jugalah graph tu macam mana. Okay. Cuma ingat kalau yang half wave rectification, positive flat, positive flat, positive flat. Sebab kita hanya guna satu diode sahaja. Untuk yang bridge akan jadi macam ni lah. Okay. Because we use 4. A to B, B to A, A to B. Okay, continuous. And then kalau nak smoother, kita guna capacitor. Dia akan jadi naik, turun, naik, turun, naik, turun, naik, turun. Okay, nak ingat lah. Samalah. Okay, naik charge, naik turun discharge, naik charge, turun discharge, naik charge, turun discharge. So yang turun ni discharge, yang naik atas ni adalah charging. That's function of capacitor. Okay, ya. Okay. Nah ini transistor. Okay, transistor nanti hari Rabu lah. Okay. Boleh tak ada soalan nak tanya? Tak ada Okay, can dismiss lah kalau tak ada soalan nak tanya. Thank you class. Okay. 25 ah. Sekarang attendance memang kena kutip each subjek kena isi attendance dalam Google Drive. Setiap subjek, setiap murid. Okay, bye.